Good day, everyone. Welcome to On the Fly Wi-Fi. Today we have a noted wireless LAN expert with us. Joining us today is Keith Parsons of Wireless LAN Professionals. Keith, why don't you say hello and maybe tell us a little bit about Wireless LAN Professionals and what you do for a living?
Oh, great. Yes, my name's Keith Parsons. You can find me on Twitter at Keith R. Parsons. That kind of gives you a little unique flavor there. Wireless LAN Professionals is a company we started, maybe 15 years ago or so. But for the last 10 years, well, when we started, it was called the Institute for Network Professionals. We did all networking, Cisco, Microsoft, Novell, Linux, anything with networking. And then about 2001 or so, we started to focus on just wireless. And so for the last 13 years or so, it's been a wireless company. And we design wireless, train on wireless, consult on wireless, and just kind of live, breathe it, and that's what we do.
Interesting. So you've pretty much seen wireless LAN since the inception, I guess. Here we are today. Probably talk somewhat about 802.11ac. I'm curious, since the onset, such dramatic changes, obviously in speeds and feeds, and what people expect out of wireless LAN. What's the most exciting or biggest change that you've seen? I guess even dating probably around 2000, maybe.
Yeah, I don't know if it's a change as much as the thing I like to see is that because of Moore's law, every 18 months we get double the transistor count on chips. Because of that one feature, everything else that's driving everything that happens in wireless. The wireless guys who do the actual engineering and understand it are probably 3, maybe 4 more cycles ahead of where reality is today. So they know how to do things. In fact, I was just talking to someone the other day about 802.1, 802.11ax. X is being a variable. We don't even know what it's going to be called yet, but the engineers are already working on things that we don't even have the chips to do today, but their brains are working on it. So I like to see, looking back to I call it 802.11 Classic, like Classic.
Yeah.
Some people call it 802.11 Prime, but that sounds like a Star Trek show. So 802.11 Classic is 1 and 2 meg only, and so you're right. The speeds and feeds have gone, phenomenal, and yet CSMA-CA hasn't changed at all, and that's kind of the driving factor. We are still stuck with frequency reuse is the driving piece when it comes to design.
Yeah, it's interesting. I mean, I follow you on Twitter. I often see you talking about channel reuse and RF in general, and even as you point out, it hasn't really dramatically changed. Some suggest with Wave 2.11ac, some revolutionary aspects of multi-user MIMO potentially. It's interesting, but you definitely spend. Sorry, go ahead.
Fingers crossed. Yeah, we're hoping it's going to do that.
But you spend a huge amount of time designing networks for people, and I guess going back to the comment you just made around channel reuse, when you're designing networks, is that front and center in terms of being able to provide capacity ultimately? Is that the first and foremost thing that you're looking for as you're designing out wireless LAN?
I would say that the first and foremost thing is you have to have coverage. I mean, if you're not going to deliver RSSI to a client device at a sufficient signal, then the device can't work. So you have to have that, but I say it's required but not sufficient. So just because I have coverage doesn't mean the wireless network's going to work. So it is the first thing, we must do it, but that alone is not enough to drive capacity. So to get to where we are today, it's not just RSSI, it's not primary. I also call the second one secondary RSSI, because instead of calling overlap, like we used to have a circle and another circle, and we'd say, yeah, we have 20% overlap. Well, if you actually try to figure out what that overlap is in percentage, the math behind that is horrendous. When in reality, what we really want is the client to have a primary, my main one I'm going to talk to, and I have a secondary to go to. So instead of talking about coverage overlap as being percentages, coverage overlap is defined from a client standpoint. I have a primary and a secondary. And that we can measure, and because we can measure it, we can show that we had a requirement and that we met it.
So it's interesting. I mean, it sounds very much like your design process is really starting from the client and working your way back in. In other words, what type of clients do you have? what type of connectivity, ultimately, what type of bandwidth and throughput you need to, I guess, achieve. Is that a fair statement?
More than fair. It's the client that drives everything. We happen to install and sell and play with the AP side, but without the clients, we wouldn't have any need for Wi-Fi. So it is client-driven. I found a lot of customers, though, don't understand what their client base is,
Yep.
and they want you to design a generic Wi-Fi without telling you what the client on the other side is. Or, oh, for all of them. You know, I want it for voice over IP handsets and for barcode scanners and for people, you know, at a college campus. I want students to be able to BitTorrent. Well, those are three entirely different designs, and you design them differently. And yet the request from the customer is, oh, just make it work.
How often do you come into customers? I think in my experience, I probably can name one. How often do you run into customers that really understands the driver behind, you know, the clients, I guess ultimately the business requirements, but really have that good understanding of, you know, the client capability is the deciding factor of how well this wireless LAN is going to work? Is it still just a widely overlooked aspect?
Well, I see a lot of customers who might know one of their clients that they have to have. So it might be the voice over IP client that's not working, so they say, let's look at that. Or a hospital that has some, you know, a Vocera badge that's having an issue, and so they say, we want to design for that one device. But usually they just want it to work. They don't think about the little issues. And so a big chunk of the design process, at least 60–70% of the time, is spent in the definition stage. Because if you can come to an agreement with the customer on exactly what defines success for them, meeting those business requirements, making sure you know all of their specific needs, learning all about their environment, that's the hard part. Because once you have the requirements locked, the design phase is actually fairly simple.
Yeah, it's interesting. I mean, usually I think most people kind of skip past that part of the design phase, which is before you do anything, before you put pencil to paper, get that broader understanding of what's going on. In your approach, would you often, and I'd love to know, you know, some of the most difficult design tasks you've been on, but do you think designing for the lowest common denominator is the most appropriate thing to do? I think some customers, at least some I speak to, say, hey, you know, I got this new high-end MacBook with 3x3x3 AC capability. That's what I'm designing to, and perhaps overlooking legacy clients or just clients with less capability. I mean, so how would you recommend approaching the design from that standpoint?
Well, the first is it's not the oldest client or the strongest client. You usually have to design for the most persnickety client. Which client has the most requirements that are hard to meet? Because if you can meet those requirements, the easy ones fall into place. Like, I wouldn't put a barcode scanner as my target goal, because you can give them crap, basically, and they'll work. They don't need hardly anything at all. Yet they're very sensitive to other issues that you need to make sure you design out. Usually on most carpeted areas, it comes down to voice over IP handsets. They're very persnickety. They have some issues you have to deal with. You have to do some extra math. There's a function that we learned, it used to be in the telephone business, called an Erlang function, where you find out what's the on balance, how many minutes per hour is each phone going to be on a call. Rather than just counting handsets, what we want to count is how many minutes those calls are actually taking place, because that's the constraint. So we start with the things that have the tightest constraints, and then work back from there. On outdoors, it might be, you know, somebody. I had a customer who said, we want to make sure. I think they were Samsung Galaxy S1s. It was some really old, nasty, hard to work with handset was their target. And based on that target, we couldn't get them to connect no matter what we did out past 70, 80 meters. And so that constraint drove the rest of the design, because that was their requirement. I think you should go back, that was like 2 years ago, and convince them that, no, people don't have that phone anymore. You'd earlier asked about what's the thing I've seen change a lot. It used to be that people would buy a laptop, and then your company would give you a new one, maybe 3 years, but most likely 4 or 5 years down the road. Whereas today, you get a new handset when that 2-year contract comes up. You're out, on top of it. I'm guessing this fall the iPhone 6s. There's so many people who had 4s and 4Ss that were just holding off, and I think there's this group of people that are just going to jump on because they've been waiting for something new. And so we see a much faster cycle of clients changing in the BYOD space than we do in the enterprise space.
Yeah, I mean that's an interesting point too, right? Because the cycle, I mean, really, if you think about it, I think you're right in terms of corporate devices being typically 3 to 5 years, depending on the lease span. Certainly, in a number of verticals, higher education is a perfect example where every September, brand new freshmen are going to have the latest and greatest, no matter what, and more than likely come holiday time around December when they come back from the holiday season. Are going to have another plethora of devices that they bring in. I've seen and certainly had conversations with customers around being able to scale, right? How do you control really the uncontrollable as these things grow and kind of just come without you really asking for it, right, or planning for it ahead of time, right?
Well, one of my customers is a school district, and this last January, before the Christmas break compared to after the Christmas break, they had picked up a minimum of 40% more devices on their network than they did 2 weeks earlier.
Yep.
It looked closer to 60 until we went back and re-looked at there were some groups that we hadn't counted earlier. But 40% once a year on growth, the compound growth on that, how do you even plan for a 5-year out when you have that kind of growth? And that's not even counting the district's own purchases. That was just the BYOD over a 2-week window. And by the way, this is K-12, not higher ed. So it's happening everywhere, not just there.
Yeah, I mean, interesting. I mean, I'd be curious, like in that particular customer, because I've had a few higher ed customers that have seen that phenomena of 30 to 40% growth in that 2-week window. Of course, at the beginning of the school year, there's all the new devices and onboarding all the devices at that time. But so in your particular case, with a K-12 organization experiencing, let's say, 40% growth in a 2-week window, obviously during the holiday time, what sort of strategy can you employ, even from a design standpoint? I mean, you got to be planning for tomorrow all the time, I guess. What would your best recommendation be?
Well, part of the way you design is we have to think of capacity in at least 2 chunks, maybe more, but at least 2. And one is those devices that come on and will take up an association slot in the AP, and take a DHCP request, and then basically go idle. At these schools, you can't use your iPhone or your iPad unless the teacher says to. In fact, you get sent to the principal, they take your thing away. But they're there in their backpacks, taking up space in those associations. So you have to design around that larger count. But there's still the same number of students, and a student normally will only be live sending data on one device at a time. And again, we can come back to that airline function that comes over from the telephone, and we can do metrics and measure and see how many minutes per hour each of the devices are being used and what kind of flow they have, and then use that to help predict what goes in the future. We did not see a 40% hit in the amount of throughput going across their WAN links. So it was localized, and it was just a change in devices more than actually growth. Whereas some stadiums I've worked at over the last couple of years, it's been 50 to 70% compound growth on the throughput. When 2 or 3 years ago, people didn't plan on using their phone in the stadium, whereas now they're out taking selfies. In fact, I was at an event, and the promoters said, "We have this really cool prize here, and the first person to send a selfie to this Twitter account is going to win the prize." And 5,000 hits got associated within the next 30 seconds. So that's the ones you have a hard time trying to design around, because you don't know what's going to actually happen during the event and how fast it goes. I had another one that said, as on the tickets, without telling us who designed the Wi-Fi, they put on the tickets, "Come use our Wi-Fi today, it's brand new," before we'd even done a beta test of it. And of course it hit, there was no DHCP pool, and they all complained that it didn't work. Well, the Wi-Fi was fine, they just hadn't prepared the wired side of the network to take the load. So there's all sorts of fun things going on there. But that's why we get paid the big bucks, right?
Yeah, yeah. I mean, it's fun. It's funny because I was at an event. I was speaking at an event recently where they did the exact same thing in terms of taking a selfie, tweeting it over to us, big prize. It always makes me think, and I mean, we do. I spend time in the stadium venue market as well, and I think what's interesting, in terms of the growth and proliferation of use in public venues, ties back and certainly interested in your comments on this, but the traffic flow. In other words, I think a couple of years ago, predominantly traffic flow was down to the clients, so from the AP or from the internet down to the clients. Clearly, with the advent of social, right? I mean, 750 million pictures a day being shared by some people's stats. Clearly, there's a huge amount of traffic that's being uploaded or going up to the access point, and I'd be curious on your take in terms of perhaps from a design standpoint, but even just from an overall impact, up versus down traffic flow, whether that impacts the network or perhaps doesn't.
Well, it impacts the wireless side. I kind of focus on the wireless side. There's other people who are good at the wired. So when it hits a switch, I blame them because I got the packet from 802.11 to 802.3. It's now yours. Deal with it.
No problem.
And so yeah, there's people who can handle that. But on the wireless side, that much the client traffic we're seeing is very dependent on the actual clients. And like iPhones have this tendency, not tendency, they do, RTS CTS in front of all their data frames. Well, that might be okay in a home environment, but when you put 5, 10, 20,000 iPhones where they can see each other, every one of those RTS CTSs takes a time slot. They have to play the game, the contention window to get down to a number, and they count down the random timer, and they finally transmit just to be able to get the RTS out, and then there's a CTS, and the whole time it's saving the frequency, and yet you have thousands of devices sharing the same frequency. So even those little teeny client things make a big difference. And that's just to associate. Once you get clients all trying to up, there's some vendors out there really good at downlink and not so good at uplink. And those ratios, as they change, it makes it much more difficult to deal with.
Yeah, so I mean, I guess it would be a fair statement that the change in traffic or the change in traffic flow certainly is making an impact on Wi-Fi on the 802.11 side. I mean, a couple of years ago, I kind of made the joke when the iPad came out that it was an RF vacuum, that it would just suck down as much data as it possibly could, that you possibly would allow it. And clearly that's changed significantly over the last maybe 18 months, even 12 months, a huge significant change in that perspective.
And we love our iPads anyway, so
I can't.
There's not much. I think the whole iOS, Android, it gave Wi-Fi, wireless sound professionals, it gave us some legs. We're going to be there's so much work to do. We're not going to be out of work for a long, long time.
Yeah, absolutely. I mean, proliferation of consumerized. I think consumerization is kind of almost like BYOD. It's sort of those things that you don't need to talk about anymore just because it's de facto. It's just life. At least to me at this point, it is what it is. You're going to have to deal with it. Soon to come, and maybe we transition for a few minutes, but I know you like to tweet about it, Internet of Things, and everyone talks about things, which I think is aptly named. Things, not just wearables like Google Glass and watches are coming. They're certainly going to be coming soon. What's your thought in terms of being able to handle perhaps the onslaughts depending on the type of customer, type of environment? What's your thought? I know there certainly are some security concerns in terms of their capabilities and the rest of it, but overall, Internet of Things, what's your take?
I just have got a bunch of these in. A little link, DSP 215s, power, access them over the Wi-Fi, great stuff. Have Nest on the wall, lights, and so obviously being a geek and liking playing with little things, I think I might be a little ahead of the game. But some of my kids had Nest before I did in their homes, so I think it's starting. I don't know if we're going to get to toaster level where every toaster has one. I really don't care if my toaster's up and down. I don't need to know about that. But it started, I think some of the first things out there were Is the Coke machine at the end of the hall, does it have, what's its temperature, and do they have any Diet Cokes left? We have so much more of that to go. In the security company who sell home security, they're actually selling more of the home automation pieces, and so that's just one piece of the Internet of Things. In the industrial side, there is every possible type of sensor needs to have its backhaul. Well, they've been using, in fact, I was working on a project a couple weeks ago where they were trying to convert serial data, very, very, very low bandwidth data. You can go over a 1200 baud modem. A 9600 baud modem is a lot, but they want to convert it over to Wi-Fi. So Devin Akins, kind of proud of saying, pushes out there. It's what we want is high volume, low bandwidth devices. So there's a lot of them, but they don't carry very much traffic.
Right.
And unlike voice data, when you're coming up a voice over IP phone, it's very little data, less than 64K. It's just really persnickety about how it needs and how to roam. I think these devices, they're not roaming very much. We'll see. There could be a whole new family of devices that need to roam. But they have a whole different way of being on the world. And it might even come down to that 256 limit per radio for association slots. You might want to adjust that. Because the AP, if it has 96K of data, well, I can have lots and lots of those. And it's periodic. So I think the whole Internet of Things might be a whole new revolution in how we design Wi-Fi. I would hope, I'm not sure about this, but I would hope that in the future we could see perhaps some new 802.11 committees who look at this and say, they really don't need the same things that a laptop or an iPhone or an iPad does. Why are we making them coexist? I think a lot of the driver is the inexpensiveness of Wi-Fi chips. But if we could find some chips that could do the same type of thing, I mean, the whole iBeacon world is out there as well with low power Bluetooth to find a way to keep the chips costs down. And I don't roam, and I don't need high volume of data. So maybe it's a whole different thing that we're going to go with. I don't know yet. This is Wi-Fi. I got a bunch of Wi-Fi stuff in the house. I still don't know. It's going to be on the internet, but is it going to be 802.11? I don't know.
So yeah, I mean, really super interesting. I mean, in terms of low bandwidth, I think that it's really intriguing. I kind of see Internet of Things, and I think you're a great example of it, as a kind of like if you go back a couple of years, consumerized products, start in the home and eventually find their way into enterprise, into the work world, if you will. Do you see, or are you speaking to customers today that are concerned from a design standpoint to be able to support even wearables? I mean, I think it's probably the greater likelihood that some wearable devices will start penetrating probably sooner than sensors and some other stuff maybe. Are you having those conversations today?
Amazingly, more of them with K-12 than with enterprise customers. The K-12s are thinking about wearables to track students, and that students their parents will want to track them by giving them watches that have a GPS functionality and Wi-Fi, so that at the school they know where they are. And I've had multiple districts ask that specific question. And when we normally design for something called one-to-one, one student, one device, but districts are now pushing that way up past 2 as a minimum. I even had one that went to 5 was their target goal, 5 devices per student. Now, obviously, they're all not going to be high bandwidth users, but the example they gave me was, well, what about if somebody wears Wi-Fi enabled underwear? And I laughed, and they went, okay, maybe not underwear, but a watch. And their parents had already started asking those kind of questions. The enterprise, the guys in maintenance and think about the building and how the building operations work, they're thinking that way, but the business drivers haven't got to the Internet of Things quite yet. We'll see.
Yeah, I think that the automation side of it is certainly hot. But since we've hit the topic, and I know it's I don't want to hit on a sore spot, but you recently published a really good kind of mini ebook, I guess you will, about 1 AP per classroom. It's kind of an interesting one. I know you could probably speak about it for hours at a time. If you were to summarize the 1 AP per classroom kind of phenomena, I mean, I think, and I know from some of the stuff I've read, certainly suggestion around lazy sales or, good marketing. Maybe it's customers that think it's very easy to just go with a 1 AP per classroom. Maybe some quick pros and cons or some quick thoughts on that topic.
Oh, sure. First, I have to apologize for everyone. I did not mean that to be so long. I started it. I got up one morning early, like 6:30 or something, and I sat at the computer, and someone had asked me a question, and so I thought I'd just write them an answer in an email. And it got bigger and longer, and 14 hours later, hadn't left my desk, had finally finished this big thing. So the idea is we should be designing wireless correctly. And by having a 1 AP per classroom as a default, I'm not saying 1 AP per classroom is going to be wrong. I'm just saying it's not the place to start. On the other hand, out of designing thousands of classrooms, I have yet to find one that needed 1 AP per classroom in order to meet their business requirements. And this is business requirements that I set at voice grade. 2 APs and 5 gigahertz at 67 or better, which basically means there's 4 radios available to anyone anywhere in the school. And we've never cleared 2.5 classrooms per AP. So going past that means you're putting more APs than you need. Now that to me either, and this is where I got to some of the lines that I put in there, that either means you're lazy because you didn't want to actually do the work, or you're a salesman and you're greedy and you just wanted more commission, or you're just ignorant and you don't know how Wi-Fi works and it's a simple thing. And I think some lobbyists that perhaps might have come from our industry pushed, like the state of Florida requires it. Well,
Yep.
Who in the lobby was able to get into there and push that kind of information and make them believe it when it's really a lie? I mean, I've talked to ProServe in the top 4 biggest vendors in the industry, and not one of the ProServe teams would support 1 AP per classroom because they know it's going to cause co-channel interference and you're going to have a whole bunch of issues. They wouldn't do it, but amazing, every one of their marketing teams is out touting it. And their answer, and this is the insidious part, their answer is, but it works. Wi-Fi is terribly resilient. Of course it works. It works all over the place. It's just you spent too much money to make it work. I mean, if a school district spent twice as much as they needed to, and it still works at half as much, well, why did we need to spend twice as much money? So that really was the crux of why I got into it. Wasn't that 1 AP classroom wouldn't work, but why did you spend more money for it to work?
Yeah, I guess ultimately, it's interesting. I won't even tell you that I saw recently a school board requesting 2 APs per classroom as their de facto standard.
I have seen that as well, and it only takes me about 10 minutes to talk to the district, and they change their mind when they go, oh, we don't need it because someplace, they don't know Wi-Fi. They're a school, but what they want is to deliver a certain benefit to their students. It helps education. And they have this pressure to say, we're going to have all these devices. And someone tells them, oh, you need 2. And they go, okay, then we need 2. And it becomes part of the RFP. It was never part of the requirements. And back to the very beginning when we talked here, it's all about definition of requirements. That's not a requirement. The number of APs per classroom is not a requirement to design to. It's what does the clients need? What are your clients? What are they doing? How much data are they pushing? How close are they together? We can even do that same airline function, classroom to classroom. What's the chances of 3 classrooms adjacent to each other all having 30 iPads running simultaneously?
At the same time, right?
And just because you could design to that, but even at that level, I've never seen you need more than 1 AP per 2 classrooms, and you still get that quality. So I don't know where it comes from. It's just kind of scary that it's happening out there.
It's safe to say. I mean, even having read your document, I mean, a lot of it is almost best practices for anyone, for anywhere, right? I mean, it's not. I mean, certainly as you just say, 1 AP per classroom. I mean, a lot of it comes down to just really sort of best practices. I know, we see a myriad of things and struggles around how best to design 11AC, and maybe we'll spend a few minutes before we wrap up. And certainly appreciate your time today. This has been a really great conversation. In terms of 802.11ac, where do you see the pits and kind of the pits and valleys, if you will, around designing for 11AC? Is it a big difference, and are you successfully designing and deploying, I guess, around 80 megahertz channels?
Okay, 3 parts to the answer there. The first is backing up to 1 AP per classroom. You're right. It's totally best practice on how to design. I've heard the same type of thing that's also wrong. Put an AP every 2,000 square feet.
Yep.
It's just any of those little short things that kind of coalesce as rules of thumb are problematic. So it's not really just a school thing on the design. When it comes to designing for AC, you kind of had a 2-part question there. One is, what are the pitfalls of AC? And the second is, what are the pitfalls of going to 80 megahertz channels? Two entirely different things. You can design today very easily with 2.4 is 2.4 is 2.4, and it's ugly and it's terrible, and we'll do our best to make it okay, but we really don't want anybody down there. If we can get every client off the 2.4, everyone's life will be better. So we're really talking about how do we focus on 5 gig. And in 5 gig, AC, I recommend AC APs to customers, not because of AC and 80 megahertz channels and we have 256 QAM and all these fancy features. It's just if you're going to buy an AP today, why would you buy 2-generation-old Moore's Law chipsets? Mm-hmm. We know the chips today that are in AC are already 1 Moore's Law late because there's a time that it takes to take the chip and get it actually into production. Yep. So we're already 1 behind. An M device, even if you have a late M device, is still 2 behind. Well, Moore's Law is the driving feature that makes everything work. So why would you not buy the latest and greatest to put in your infrastructure? Because it's the slowest to rev. We can rev our clients out every 2 years, or maybe every 4 or 5 years. But your infrastructure is a 5 to 7 year plan. So if you're going to spend the money to put in hardware that's going to last 5 years, at least get the most cutting edge you can today. Not bleeding edge, but the cutting edge. So the AC sale is really, who cares about AC features? You want to just buy latest chipsets. Well, getting that latest chipset also gives you all these other features. But they really only come into bear for that MacBook Pro with the 3x3 that can get, I think mine's getting 867 is what I'm pulling off right now. Yep. But my internet connection is 50 meg. So no matter what I do, it's not the bottleneck. And it hasn't been the bottleneck for a long time. What you want that newer chipset for is all of those single stream devices. But I can handle more of them, and when they talk, I have MRC that can listen and decode it and get a cleaner signal back. Yes, we can blast our APs out and have a lot of downstream power, but it's always been the client getting back the AP that's been the constraint. Well, if I have better ears on my AP, then I can hear those guys when they're weaker. So that's kind of the whole thing there. And for 80 megahertz channel side, why? I don't even, people talk about it because it's cool and it's words, but one, I would rather have more channels and less co-channel interference. Because co-channel, of all the design specs, and I have a list of about 10 short ones that I always hit, and then 20 when we get into voice. But on the short list, there's primary signal strength, secondary signal strength, SNR, and co-channel interference. The first 3 are easy. If you want more coverage, just add more APs in terms of power. But the one that's difficult and the hardest is to get rid of co-channel interference. Take away the number of channels I have to keep frequency separation, and it makes my job really difficult. And I don't have any clients that need 80 megahertz, so why am I going that route? I would just rather have more 20s or more 40s if we could.
Yeah. No, it's interesting. It's definitely what we see. Certainly, most of the customers that we've been working with, kind of down the same path of, latest greatest technology is the new AP better? Well, just by fact, it's better. There's better components that are put into it because there's newer, exactly like you said, Moore's Law. You're going to have newer stuff available to you, and 40 megahertz, even 20 megahertz. Some of the stadiums that we've designed and deployed a huge amount of bandwidth with 11N, properly designed 20 megahertz in and across 5 gigahertz. And I think, unfortunately, too much hype gets thrown out there these days in the marketing and press realm that really confuses everyone. So
But
maybe
isn't that their job?
what's
I
that?
thought that was the job of marketing, it was to confuse people.
So maybe to throw out a final thought before we close off. Wave one versus wave two. I know it's a huge conversation. What's your thought? You wait, you go. Promises that won't be delivered. Where are you at?
Again, come back to clients. How many Wave 2 clients we have? 0. And yes, Wave 2 may be better, should be better. We hope it's better. Yes, but why would you wait? Now, if today you have late generation N gear and it's working fine and you had a good design and your Wi-Fi is working, well, I wouldn't rip and replace today for AC even.
Yep.
Let alone, so yeah, maybe we were wait for Wave 2. But we're not really waiting for Wave 2. We're waiting for our current installed infrastructure to have a reason to change. If it doesn't have a reason to change, why even change today? Now, if you're doing a new install, a new school, a new wing in a building, well, you want to put in the latest and greatest today. So I wouldn't put in N devices or not put in anything waiting for Wave 2. So I'm not the wait and see kind of guy. If you have a need and we have gear that can solve the need, that's what you put in. Pretty simple.
Yeah, I think I would tend to agree. Well, hey, I certainly appreciate all your time and all your advice. Certainly have a lot of respect for you and your organization. I know Wireless LAN Professionals and the Wireless LAN Pro conference you were mentioning to me, potential to do one in Europe and hopefully another one.
The Europe one, we picked a date and location, so we'll be announcing that shortly. And then we'll have, obviously, another one in the States in February time for next year. So glad to have more people come.
Yes, for sure. We'll definitely help to promote. I think it's an excellent organization, certainly an excellent resource for all of us wireless LAN professionals.
And we have Tech Field Day coming up. Yay, yay.
Yeah, exactly.
Now we're going to see more from Extreme. We just got the taste last time around, so we're looking forward to it.
We're planning as we speak, and certainly we'll take any feedback or requests, and we can do that on another channel.
All right, appreciate it.
Well, hey, thank you very much, Keith.
Have a great weekend.
Yeah, you too.